Hi guys, welcome to TechoGenius Academy. We are industry-led training providers for those who wants to build their career in data science, analysis, IoT, device driver, embedded Linux and many more. Please do like, share and subscribe to our channel.
Hello all, welcome to the TechoGenius Academy. Yes, we are back with another session in Linux device driver. So many guys requested that we need Linux USB driver, and there are so many material already available over the internet that will give you the idea that how you connect to the USB device and how you can write the drivers and all, but they were facing like issue in probing and all. So I thought of like, okay, so I have to develop something. I have to write some code and all. So, and I'll share some of the information. So whatever I'm sharing it with you, it's already readily available over there. So I'm just taking few of the information and I'm just putting it here. But in depth, you can definitely go over there. Yes, whatever the APIs, whatever the structures will be used in the USB device driver. Definitely, we will take a look into that, and whatever the basic things available. And whatever the basic things need for the USB device driver, we'll definitely look into that. So, without wasting any time, let's get started. We will start from the introduction, and later we will just jump to that structure or whatever the registration call while writing the USB device driver. We need to take care, and we will just see that, and directly we will jump to that code and all. Okay, so I'll try to cover both the sessions in this video only, so you will get the maximum benefit. Okay, so yes, so USB stand for Universal Serial Bus, as you already know, and basically it promised a easy connection of multiple peripheral devices to one port or like an automatic. Hot plugging is there. So hot plugging is like when you connect some USB pen drive to that system and all. So it will be prop, and you can see in the message logs also. So you can say as a hot plugging, and the configuration of the devices which is attached to that system is also there. So it will permit the connection to that thing. So there are multiple peripherals where like in which USB port is connected, like scanners, network cards, modem, keyboards, mouse, etc. So there are so many peripherals available in the market, and whatever the USB related documentation you can find in this directory. So yeah, and the basic thing and the main thing which we just need to concentrate more, and we just have to understand, is that a USB subsystem. So the USB system will have USB core, USB host controller, and the host controller driver, and you just need to take care of these three things, and these things is in the kernel space, and the USB controller, you can say it will help to communicate between the host system, whatever the system you are using, and the USB device, and the USB device means your hardware only. Okay, so you have that user application, and which is like where you will write the user mode driver and all, and which will interact in the to the kernel space. So via USB FS you can interact with that, and the kernel space driver, whatever the USB device driver is there, it will communicate with the USB host controller driver, which will further talk to the USB device, which is in the low level in the hardware space. Okay, so The corresponding host controller driver would pick and translate the low-level physical layer information into the high-level USB protocol specific information, and the USB protocol formatted information about the USB device is then populated into the generic USB core layer. So generally, is like whatever the USB you are connecting, it will generally call the generic USB driver in the kernel space. Then it will enable the detection of the USB device in the kernel space. So even without you having it's a specific driver or not. So what we will do, we will just remove the generic driver, and we will try to probe our driver which we have written. Okay, so yeah, this is the stuff, and the USB core is code base consisting of routine and structure available in the host controller driver and the USB driver. So we will look into the routine and the structure which is available in the USB.h header file, and we will go further into that, and we will write into the code. And yeah, so the other main thing which we need to concentrate on this is a USB descriptor. So USB descriptor is nothing but you can say it's a unique device descriptor which will have a few components, like it will have the one or more configuration, and these configuration will have multiple interfaces, and those multiple interfaces will have multiple endpoints. So what are the basic use of these like diagram which you are just seeing on the screen is like the device descriptor is where basically give you the information about the product ID and the vendor ID. So how you will get to know about the vendor ID and the product ID? So whenever you are doing ls USB, okay, ls USB. So as you can see here, this is 27C6, this one. So the one of is this the product ID, and the other one is the vendor ID. So for the detailed information you can do ls USB -b. Okay, so yeah, so the device descriptor will have this ID and the number of possible configuration descriptor will what the device have. So the device descriptor will have how many configuration descriptor that can be decided by the device descriptor. So the configuration descriptor has the information that how that device will be used, and but we can enable only one configuration only. So whatever we need to use, either it's like first configuration or the second, or like how many, like if there are multiple configurations are there, so out of that only one configuration at a time we can enable that. So each configuration points to one or more interface descriptor, and more descriptor means like if you are working on the camera, if you want to see about the camera and all, so that will have the different settings like modulation, the bandwidth, the resolution, and all these things. So different aspects and different settings will be there in the camera. So interface will point to those settings and all. So yeah, and after that interface will is connected to the endpoints and all. So endpoint descriptor which give the data source or a sync to the device. So to understand about the endpoints, like basically like how your USB device will be communicated between the like how you how it will transfer the data. So the USB endpoints, in the USB endpoints there are 4 different ways to transfer the data on the USB bus. So one is the control transfer, interrupt transfer, bulk transfer, and asynchronous transfer. So the different transfers are there which will be used to communicate between the USB bus. So this is the some basic introduction or basic stuff, like in the control transfer also, like you can use to transfer the information like resetting the device and all. And in interrupt transfer you can use small or fast data transfer, but in bulk you can use high data transfer. In asynchronous, or there'll be also like big data like transfer can be happen, but with the bandwidth guarantee, but the data integrity will not be there. So in some of the transfer, bidirectional transfer will be there, like in the control transfer, but both in and out endpoint will be there. But in asynchronous, like it can be either in transaction or the out transaction. So it depends, like what kind of USB transfer you are doing. Correct. So the more information definitely you can get over the internet. So what I will do, I will share some of the links over the description, so you can get a maximum benefit. So yeah. So please just don't forget to like, share, and subscribe to our channel and all. So if you have any doubt and all, please mail us to techogenius7519@gmail.com and the support@techogenius.com. So yeah. So what I will do, as like I don't want to complete in one session only. So I will just go and jump to that another session where I have like I will explain about that whatever the structures we need to use and all, and about the advanced USB device driver. So like yes, we were planning to do some advanced Linux device driver on Beagle Black. So where people were talking about the they want to learn ISKC, SPI or PCI driver and all. So yes, we are soon going to upload the session and all. Definitely the course will come, but later days and all. So our team is working on that. So yeah. So what I will do in the further session. So this is like advanced Linux device driver on Beagle Black. So we have we will discuss about the USB device driver. So we have discussed ISKC device driver in the two sessions and all, where we discuss about the framework and the low level programming, the low level hardware, how it will be communicated and all, and where we discuss about the ISKC core, ISKC Raptor driver and all, and we developed the ISKC client driver also, and we ran that. So yes, and further definitely we will jump into the user mode driver also, and the adapter driver, which will be used by the ISKC core driver and the user mode driver, your user application. Then we can communicate between the ISKC master and slave. So that will be done in the later session. So today, like what I will do now, I will just directly jump to the USB device driver structure, which we need to use. So the USB driver structure, it helps to register itself with the Linux USB subsystem, and we need to give some information about that, what that device supports and what function to be performed, which is like inserting or removing the module. Like while you are doing inserting or removing the module, that time like it will help to give the information about that, and later this information is passed to the USB driver structure. And the USB driver structure, actually there are multiple members available in the USB driver structure, but probably we will use probe, ID table, name, disconnect we will use. Basically the probe is when device detects the USB bus is connected, and match is the vendor ID and the product ID, that your driver is registered with the USB call, then this function will be called. ID table is generally is used for the hot plugging, which I have discussed earlier also, and which hold the sets of descriptor and specialized data, like the vendor ID and the product ID. We will use that USB underscore device macro to and pass the parameter of this product ID and the vendor ID to that ID table structure. And there is a name also, so we need to give the USB driver name also. So we will give that name, we will give, and the disconnect is basically when the device is disconnected. So that time we will use this disconnect. There will be a file operation structure also, and there will be USB class driver structure, which will be used while invoking this driver and all, and like when you want to register the device and you want to deregister the thing, So that time when you want to disconnect, that time it will be used. So register the USB driver to the USB core. As you can see, the USB system also, we will use this USB underscore register in the init call, and in the while doing the deregister the USB from the USB core, probably we will use this USB underscore deregister. So yeah, so this is the thing which we need to use while working for the USB device driver. So yeah, so without wasting any time, let's get started. Let me just connect the USB pen drive. Just wait for a second. Yeah, so let me just connect my USB pen drive, and I will go to the terminal. Yeah, it's connected. ls USB. Yeah, so as you can see, here is the AA. That is nothing but your vendor ID, and 8816 is your product ID. If you want to get some more information, as I have explained you earlier, that there is a command like lsb usb -v, where you can find like it's quite good information you will get. Let me go to that specific thing which I was looking for. I just want to show you. Just wait for a second. I'm just looking into that. Yeah, so as you can see, here is the vendor ID is AA88 0x88AA, and the product ID is 8816, and you will have see, like, the device descriptor is there. This is the structure which will have this members and all. There will be a configuration descriptor also, which will be available in the usb.h header file, which we will use that hash, which we will use the header file. There will be interface descriptor, there will be endpoint descriptor, yeah, so which will have these parameters and all. Okay, so we will use this structure and all, and we will try to print some values and all, what will be the values and all, and we will check. So, and we can compare with that, like whatever the information this is giving is correct or not. Okay, so yeah, so this is pretty much good. So let me just go to the super user, like sudo su. Yeah, so I will write, like, I will just create the driver USB. Okay, so let me say, like, Linux USB driver, cd Linux USB driver. Okay, so yeah, so sorry, what we will do, we will write the driver which will include your all the structure and the API, like whatever the calls, that kernel calls we have seen, we will use that. Okay, so yeah, USB test underscore drp.c. Yeah, so we will write Linux USB device driver. Okay, so we are we just adding the header files and all. So basic header files which will be used in the module programming if you are not aware of these stuff, please go and check out my earlier videos. Like I have developed I have uploaded multiple videos in the Linux device. It's like it's like now huge. So yeah, in the future we are planning to shift to some RTOS and different Linux also we will use. We are writing it here only. Maybe in future we will use Zephyr. Okay, so yeah, so can we just write the macro here? USB vendor ID. This looks quite good. USB product ID. Okay. So like one by one, I will just write the structures. Okay. So the functions and all the whatever the modules I will do. So first I will write the init and the exit module, and I will write the macros which will call the initialization and the exit module. Correct. So yeah. So let me just write that. We will use static here, static and underscore init USB test init void, and we will use USB register call. Okay, so USB register call we are using. For that, what probably we need to do here is we need to, I will just write the skeleton. One second. Okay, struct USB underscore driver. Okay, my USB driver. Let me just USB register. Okay, let me declare the structure. USB driver structure actually I have to declare, so which will pass static struct. Okay, USB driver structure. Okay, so I can say USB drv struct. Okay, as I'm saying that USB driver structure will have the, okay, so TechoGenius USB driver, correct. Probe, which will definitely will be called when we will connect our USB pen drive. USB drv probe, this is correct. Disconnect, I'll just make it Just do the indentation. Okay, USB DRV disconnect and the ID table. It will like, we will use the macro here and pass that parameters, that vendor ID and the product ID. Yeah, so this looks nice. So I'll just pass that structure to it. Address of USB DRV struct. Here also address of USB DRV struct. Okay, so this looks nice. Now I have to add module underscore init USB DRV. Okay, USB test init USB test exit. Correct. Now I will write module license GPL module author. You can use this same driver over the BeagleBone Black also. So I'll just, because I'll just connect to my host machine only. But if you want to do, you can just build it here, and after that, like, you just need to check that out that whatever the USB pen drive which you are connecting, whatever the product ID and vendor ID is there, and you have to disable the generic driver over there, and you have to enable it. So you have to do some settings and all, and definitely you can run this same driver over the BeagleBone Black. Okay, so yeah. Okay, this looks fine to me. Correct. USB test driver. Okay, so please guys, in between, like, I'm just saying, because please like this session if you understand some of the bits and all, and please don't forget to subscribe, because if you'll subscribe this session, then only it will be more encouraging for us also to put more videos and all, just to help you guys over there in the like, who are sitting in another table in front of me. So whoever will watch this session and all, so it's my kind request, please subscribe to this channel and all. So yeah, so back to this thing. What I will do, like, I have just written the init and the exit module, and the next thing what I will write here is the table. So whatever the table we have written here, we will just write the table to understand in a more generic way, so that that table will work with the driver and all. So I will use the macro also. So I will just write it here: static struct USB device ID. ID table I have to use. So like USB. So okay, so what I will do, because I'm using by P D, okay, because I need to use this one now. USB DRV, this one, this table, okay. So probably like I will call USB device and I will pass the vendor ID and the product ID. USB vendor ID, USB product ID. Great. Yeah, so after that I will just call the module device table, which will probably we are using, and the understanding like I have explained in multiple sessions and all, so you have that understanding. So I just want you to comment over there in the video. So what is the answer for that, like what why we are using this thing? Okay, so I have to ask the question to you also, na? Then only I'll come to know that you are understanding or not. Correct? So the next thing what we will write here is the probe. So because we have written the ID one thing, so probe and disconnect we will write. Static int USB DRP probe. We will use the USB interface, like whatever the different interfaces are there, and we will use the device ID also. So that is basically used for the probe call. So struct USB, so that I have already explained you. If not, okay. So let me go to the this one. Yeah. So this is a USB.h file, which will be present in include Linux USB.h, and there will be a multiple structure like USB host interface, USB interface conditions, USB host endpoint. There will be a USB driver structure also. It's there. So there will be a multiple structure is there. So which will be used by our driver. So we have already used Linux/USB.h. So we know that the structure is present over there. Okay, so yeah, we will use the device ID, and here if you want to print some of the information about that, how many endpoints are there, how many interfaces classes are there, what will be the product ID, what will be the vendor ID, and all these things, what will be the interface number and all. So you can you can use this thing, but you need to declare the structures to use that thing. So if you want, like I will, okay, so I will just write some of the information, but the detailed information and all you can get. So whatever the LSB USB hyphen V we have done, in you can use any of the structure, the device descriptor structure, endpoints descriptor structure, anything. Just declare that structure variable, that pointer structure pointer, you just declare that, and you can just make that variable arrow, and whatever the member is there. So if you want to print that value, and just print that value, and you can match it over there. So probably like I will use some of the parameter, like I will just print up product ID and vendor ID and all. So it will give us the information that the correct USB device is probed. Okay. So the USB host interface I am using. So USB interface, like it's an interface descriptor. So like I will just write interface. Okay, interface descriptor. Okay, and struct for endpoints, like descriptor. This structure is already present, like I have showed you in the usb.h. Just need to declare the variable for that. Interface. I'm just pointing it to that. Current all setting. Okay. So I'm pointing to that whatever the alternative settings are there. So it will point to that interface descriptor, and from there I can get the interface number and all. So ls usb -v will give me the interface number. Interface descriptor is there now. This one. Okay. Okay. Correct. Kern info for error, like you can just, because I have not done any kern error thing here, so please remember. So if I'm just writing it here, but like definitely we have to use this error condition. Like if it fails, then you have to return it out. Okay, just need to return it. So percentage specifier, I'm just putting it. Interface number I will print. Vendor ID, vendor. The parameter, the structure parameter is like that only. ID vendor, ID product. Endpoint. Then how many interfaces classes are there? We will just print that. Correct. So we got some of the information and all. You can get more information, like whatever the endpoint address, whatever the packet size, like as you can see here. So interface class I have we have done and all, but if you want to get the more information about the endpoints or something like that, like whatever the endpoint address is there, whatever the attributes are there, whatever the packet size, there are multiple things, like whatever the information you want to get it, you can just declare the structure and you can do that. So the basic thing, like I was just explaining, I am explaining you because then you can have that idea that how to write the driver and all. Okay, so now what I will do, there is a one okay, there is a one okay, let me now there is another USB class driver. Okay, so I've not written about that in my session, USB class driver. Okay, 1 second, let me class driver in Linux. Okay, USB class driver structure. Okay, so what it says, this USB class driver structure, it will identify the USB driver that we want to use for the USB major number. The structure is used for the USB registered dev and the USB unregistered dev function to consider a number of the parameter used by them. So if you want to get the minor number or major number and all these things, then probably you can take you can use this USB registered dev and all. And like if you want to disconnect this thing, so you can put the USB unregistered, or you can use USB deregister also over there. So that will be basically used for that. So what probably like I will do, I will just take this, or if you don't want to take that, that is purely up to you. So like if you want to print the value and all, so you can print that. So there will be a, in the USB class structure, there will be a name, there will be a file operation structure also, and the minor base also. Okay, so if you want to use, you can use it here. Like you want just use like you can declare here int return and return USB register dev interface. Okay, you want to use interface, and the structure you need to declare now. Structure USB class driver. Okay, and you can just give name like USB class driver now. So USB class, okay, USB CD, okay, USB CD. So you can just make it here like USB address USB underscore CD. Okay, so you can say if RDT is not like that, then you can say print k con info not able to get the minor number. If we take, then you can say here is print k con info minor number equals to %t/n interface hyphen minor. Great. So similarly, you have to write the disconnect function and you can just deregister the driver. Deregister or unregister you can use. USB class driver. Correct? Con info d you can say disconnected and release the minor number. Okay, and if you want to print, you can print also. If we are using that interface thing, why would we call it? Great. And you can just print it here also. Con info register the USB driver with the USB subsystem. Okay, and you can just do here is the deregister the USB driver. So is this this looks nice. Here what you can use the file operation structure also, where you will use the open and open, close, read, and write for the data transfer and all. So, but as we are not going up to that, we just want to probe the USB driver. Okay, whatever without like whenever we will connect our USB device, correct? So nothing less, nothing more that whatever we need to use. Okay, so yeah, so let me just quickly write the make file. Kernel directory slash lib slash modules. We need to mention the kernel. We will use the shell uname -r slash build pwd present working directory. We need to pass the shell pwd. This looks okay to me, like an R. Okay, so default dollar make -c dollar kernel directory subdirectories dollar pwd modules. Okay, now install module underscore install clean clean. So this is pretty much good. Let me just run make. Okay, 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 so there are some errors. I need to check that out. Give me some time. 26 is that error? Okay, okay. Okay, just 1 second. Okay, so I have solved the issues and all. So actually the issues are here. So I have not mentioned that comma here. So I've just mentioned that comma. So everything is solved. So now I'll do the make. Yeah, it's done. Yeah, I got the kernel object file. Now the exact thing is ls mode. This USB storage driver is already there. So dmessage-c. I will just okay. So I will remove sudo rm mode uas rm mode usb storage. I will remove. After that I will just insert my USB driver. Now I will just check the message. Registered new interface driver, TechoGenius USB driver. Okay. Probe is failed. Okay. 1 second. USB storage. Okay, USB storage driver is connected now. Okay, ls mode head -5. Okay, now what I will do, rm mode USB test driver, rm mode uas, rm mode USB storage. Okay, that is already used. ls mode. Okay, it is in use. Okay. Ins mode USB no such. Okay, ls. Okay, sorry. ko d message. rm mode USB ls rm mode USB storage. Okay, done. Now I will connect my USB driver. ls mode, it's there. rm mode USB storage. It will not be used because it will be used by UAS. Okay, then I will do, it's in use only. It is used by 2. Other than S0 na ls mode used by 1. Okay, let me just close this and open again. Zero rm mode USB storage. Okay, d message -c correct. ls mode. Okay, ins mode USB driver ko d message. So we got that. See, USB info 0 now propped. We got that number, endpoints interface number and all. We got that, but it is somehow registered also with the ls mode. Our USB driver is not there, but it is probed. But some of the information like uh, is not proper. We will just look into that. What is that exact issue? Okay. Yeah. Make clean. Oh, sorry. Make ls mode, rm mode, USB test driver. Make clean. It's like confirmation, like our USB driver is probed. Okay, so we will just look into the exact thing like what we have written. Yeah, it's correct only. See, we register the USB driver with the USB system, subsystem. Everything is printing here, okay, but not able to get the minor number. So I'm not sure like why it is giving me this. Uh, okay. Hmm. Actually, I just need to check it out. Our basic thing, what we want to achieve is like we just need to collect the information, and you can just compare it with this one also, ls usb hyphen v, and whatever the information is present over here, you can match it to that whatever you got it. That will give you the same result. See, interface number is 0, that endpoint is 2. So in this way, like, you can get all the information and all. So I just have to look into the USB class driver, that what happened, what went wrong, and probably like I will mention the solution to that comments and all. So yeah, so yes, we are pretty much understood about that, how we can deal with the USB device driver. And if you like this video, please don't forget to like, share and subscribe, and we will meet to the next session, where we will discuss about the PCI device driver, and probably we can discuss about the other drivers also. So thank